Hey everybody, how you doing today? Welcome to the podcast, Breaking Biotech. My name is Matt. Thank you guys so much for watching today. If you like what I'm doing, please like, subscribe, or leave me a comment. I got a bit of a different setup because of a water incident with my laptop this week. So unfortunately, the document that has my portfolio overview is on that. So we're not going to do that today, but I do have some good stuff. So it'll be good. My desktop's on the left, so if you see me looking over there, that's why. So the lesson is don't keep water next to your laptop because it'll cost you a lot of money. So anyway, today we're talking about Sangamo. If for those who didn't pay attention, the stock basically dropped in half last week based on the updated data from their Champion study and their Empower study, which was their products to help with MPS I and MPS II. So we're going to talk about that and kind of give my perspective and thoughts of the future of the company. Okay, so for those who aren't aware, Sangamo is a bunch of different products related to gene therapy, and they've very much been, I guess, the pioneers for zinc fingers, at least the biggest advocates for zinc fingers, which are enzymes that are used for genome editing. So they're the generation of gene editing tools that came before CRISPR got all excitable. So and they work in the lab. People have used them for a while for different research reasons, but they're the ones that have used it in the clinic anyway, or tried to use it in the clinic. So they have programs for MPS I, MPS II, which is a deficiency in enzymes that degrade mucopolysaccharides. So when these build up in the body, it leads to a lot of negative symptomology. And it's very, very sad for these kids because they have a very difficult time. But so the current treatment is enzyme replacement therapy, a treatment offered by BioMarin, and Sangamo is trying to figure out a way to deliver the gene to these patients so that they can produce their own endogenous enzyme and supersede the need for enzyme replacement therapy. So, it would be great if this would work because it would definitely improve their conditions of living. The other programs that are particularly noteworthy are the hemophilia B, hemophilia A, and beta thalassemia and sickle cell disease. These have a pretty big market, so it's a good opportunity for them to generate some revenue. And they also have some early preclinical programs that we're not going to talk about today. And I haven't really looked into them, to be honest, because, I'm more interested in the ones that are closer to the clinic because, if Sangamo has a chance of being a viable company long term, they need to come up with therapies that are revenue producing. So, so they presented at the WORLDSymposium in 2019 in Orlando, Florida, and two presentations. One on the Champions, which is their SB913, and the second one was Empowers, which was SB318. So I'm going to first talk about their preclinical data that they published in 2018, and I think that sets a good base for understanding their human data that they presented last week. So they did a lot of great work to show that this could work in mice, and there's models for MPS II in mice, and they use this combination of vectors in these mice to show good activity of the enzyme and a good reduction in the GAGs, and even some behavioral studies, which sometimes the mice don't usually, sometimes mice don't behave well with those kinds of studies, but they did show that. So just to give some background, the layout of what they're hoping to accomplish is here. So what they want to do is use zinc fingers to insert a gene, this HIDS gene, which human iduronate or something, 2-sulfatase. The enzyme that's involved in breaking down the GAGs is what they have here. So they want to use zinc fingers to insert this gene in between exon 1 and exon 2 of the albumin gene. And the albumin gene is very highly expressed in the liver, so what you would expect is very high expression of this IDS gene in the liver that would then be secreted into the blood, be taken up by tissues, or circulate in the blood to break down these GAGs that lead to all the negative symptomology. So what you end up having here is this exon 1 fused to the IDS gene that targets the IDS gene to get secreted and exist as a protein like that. So it's a good idea. It's a novel idea. The thing is that makes it difficult is you need 3 different vectors to all infect the same cell in order for this to work. So there's a vector that has the zinc finger 1, a vector for the zinc finger 2, and then a vector for the actual donor gene that would go into that locus here. So in mice, what they did is after they did this infusion in their MPS II model mutant mice, they looked at IDS activity in the blood, they looked at IDS activity in the tissues, they looked at detailed genomic analysis to look at insertions into the genome, so you can measure that using a sequencing technique. And then they also looked at the output, which was GAG levels, or they did behavioral studies, but I'm not going to show that. So in the mice that received the donor, the donor zinc or the donor gene viruses, that's what I want to say, the AAV viruses, they saw a nice increase in activity in the blood, in the plasma after the delivery. They also saw in the tissues that they got hundreds of fold increases compared to the MPS II mouse. So, this is huge in all of these different tissues. Even though the activity would only be limited to the liver, once it circulates through the body, a lot of these tissues will take it up. So they saw that very strong effect here. The insertions and deletions they saw in the ones that received the different doses, a dose-dependent increase in the number of insertions and deletions, which is showing that actually at the genomic level that it worked. And then they followed it up by looking at GAG levels that were reduced greatly. So compared to this green bar here, they saw that the mice that got the gene therapies of different doses had a substantial reduction in GAGs, which is what you'd want to see. So, I thought that the publication showed very nice correlation between the effect of the gene therapy at the local level, and then they saw these systemic improvements in the mice. So if we want to compare that to the humans, and the AAV is a little bit different. So they used, they called it a recombinant AAV6 for humans, even though in the mice it was AAV2 and 8. And this is something that, I think Spark had to deal with this a lot, that they don't necessarily correlate between species. Humans have different responses to different AAVs than mice do, so this is kind of this is going to be a growing pain for any company that wants to get into gene therapy, is figuring out the right AAV for the right tissue that you want to target, and the one that's going to have the least amount of reaction from the host immune system, because it's a virus. Okay, so in this study they did 3 different doses, 5 times 10 to the 5 times 10 to the 12 vector genomes per kilogram, 1 times 10 to the 13 vector genomes, and then 5 times 10 to the 13 vector genomes per kilogram. So 3 different doses, and they looked at plasma IDS activity. And as opposed to this guy here, we're falling flat in pretty much all of the patients, with the exception of subject 6. So subject 6 did see a marked increase in plasma IDS activity. This patient had a lot of issues besides this, so transaminitis that occurred and a hernia that occurred. So this patient had to quickly go on some steroid usage, and this could affect the gene therapy itself. So the levels ended up coming right back down, but this subject here was relatively encouraging to the scientists. I'm this is not very positive data to me. So if you look also at the GAGs, so this is the output, and we saw some of this data earlier in the year in September, and basically they're unchanged. So you would expect a dramatic decrease in GAGs if the treatment worked. And even in subject 6, we don't see a decrease in GAGs at all. So, and these are all patients that are on ERT therapy. So compared to the mouse, which we get this big decrease, we don't see that in the human. So this is largely negative data that doesn't show that the treatment worked. Now, from a safety perspective, it looks like all the adverse events weren't really associated to the gene therapy, which is good. But it doesn't look like there's very much efficacy here. Now, if we're going to talk about efficacy, there's a couple things to look at, right? They want to know what the obvious questions are. Were the viruses able to deliver... Oh, sorry. Hang on. My video here is dying. Okay, 1 second. Okay, we're back. Okay. Thank you all for bearing with me during that, and the dog's here. Okay, so gonna get to it. There's a couple questions, right? Did the viruses work? Were the viruses able to deliver the gene products to the cell? And there's ways to do this. If you put some sort of marker like a GFP that's tethered in the virus. You might not do that for humans because you don't want to cause any other concern of safety. But the other thing you want to know is, did the gene editing work? So did the actual zinc fingers do what they needed to do once they were in the cell? So what these guys did, though, is they used a RT-qPCR assay with primers that were specifically designed over this albumin exon 1 and the IDS gene itself. So you're only going to see a product if this mRNA molecule exists in the cell. And they used this, and they said that they got negativity in cohort 1, but positivity in cohort 2, in both patients of cohort 2. Didn't talk about cohort 3, some problem with the biopsy, and they're waiting on some results. Now, for those who aren't super familiar with PCR, or reverse transcriptase, real-time PCR, this is a technique to quantify mRNA in a cell. So they reverse transcribe these mRNA molecules into cDNA, and then they use PCR using primers that are specific to a certain region to quantify how much cDNA is in that tube or that sample. So, this technique, it gives you, it's got like a range of detection. And it tells you, actually it quantifies how much of a product is there. And they're not really telling us that. They're not telling us what they used to say that something was positive or negative. You can look at the cycle threshold, which is the number of cycles that it takes to get the amplification of that product to tell whether or not there's a difference in expression between two different samples. So I would love to know what they consider to be a negative sample and what they consider to be positive. And, this would also help us to determine the amount of expression they're getting of this gene, and does it compare to the native albumin that they expect. And they don't tell us that here. So this is a little disappointing to me. I would have liked to see something deeper here. And related to that, their publication, they did Western blots on tissue samples. So, this is actual protein, the presence of protein in a tissue. And, with a biopsy, you don't need a lot of protein to do this assay. And the fact that they're not showing us that either, it's not super encouraging to me, and it just doesn't bode well in terms of confidence, which is already lacking given what they showed us in September. So I'm kind of disappointed in this. And then they also did that insertion deletion assay, and they were unable to detect insertion deletion events in all samples tested. And they say that this is less sensitive than the qPCR assay, which is possible, but with their lower limit that they say here of 1 in 1,000 genomes, that's a less than 0.1% transduction efficiency or zinc finger efficiency. So, that's very, very low. And for them to expect that few number of cells would be able to produce enough IDS to have a clinical effect on the GAGs is, it's kind of obvious to say that it won't be enough. And and that shows up in the low amount of IDS that we see in the blood. So them saying that this is positive, I don't really like, and them saying that they're unable to detect it in this much just makes me think that the either the zinc fingers didn't work or the AAV isn't ideal for hepatocytes. And this goes back to what I was saying before with them needing the 3 different vectors to go into the same cell. And it's difficult enough to get one vector to transduce into one cell, but to get all 3 in the same cell, you can imagine that the probability of that happening is a lot lower, and it's a lot more difficult. So so I'll talk about that a little bit later. But so in the presentation, they go on to say that they're going to do ERT withdrawal in these patients. 3 of them had already had ERT withdrawal, and 1 has already gone back onto ERT because of fatigue and an increase in GAGs. So they're going to do it with the other patients and hope for the best. So their conclusions here were that it was well tolerated. They saw an mRNA transcript in both subjects at this middle dose. Again, I would have liked to see more details here before I really believe them. They said that they saw increased plasma IDS activity in 1 patient, even though that activity decreased after the transaminitis, and then they're going to expand their ERT withdrawal. Okay, so from this, to me this just looks like there was an issue with either the virus or with the zinc fingers. But all they talked about on the call was that, this is good preliminary positive data. And they're right, seemingly, if you believe their qPCR data, then they managed to get gene editing with their zinc finger technology. And it didn't necessarily lead to clinical benefit, but, it apparently worked. Now, given that, all they talked about on the call was how excited people should be for their zinc finger 2.0 technology, which is going to increase the efficiency of the insertion event. And if we should be so excited about these preliminary data, I don't know why they're focusing so much on the zinc finger 2.0 technology. Because if the gene editing itself worked, then it's really a problem of getting the AAV to transduce as many cells as possible. But they didn't really show us any data to that. And, we don't know whether or not these patients developed autoantibodies against the virus. And I'm not sure exactly how efficient this virus is in human hepatocytes, which are a tough cell type to work with. So, I think this is likely to be a problem. And I think that if they're ignoring the fact that the AAV might be an issue, that this could be further problems down the road. If they continue to try their zinc finger 2.0 technology, but they stick to the same AAV, it could lead to the exact same data. So the other thing, maybe the zinc fingers didn't work, and I'm suspicious of this qPCR assay. Just saying that it's positive isn't super helpful, and also the fact that they got such a low efficiency. It just makes me think that it's more a problem with the virus than it is the zinc fingers. But also, it's the fact that they need all 3 of these vectors in the same cell that I think is difficult for them. So I think that this is going to be a tough lesson that they're going to have to acknowledge. And, I could be wrong. The ERT withdrawal might work, and that'll be great. But before I talk about that, I'm just going to go over through their MPS1 data real quick. The only things that were important, really, and the things that the guys on the call were very excited about was this leukocyte IDUA activity. So instead of IDS with these patients, it's IDUA, but it's the exact same principle, 3 vectors, and they're hoping that it gene edits in the liver, and then the albumin promoter will increase the levels of IDUA in the blood and in the tissues. So one way to look at this is IDUA activity in cells. So they took leukocytes from the blood, and I assume from the blood, and they measured IDUA activity. And what they saw was a nice increase in IDUA. So this is actually relatively encouraging, especially with a low dose and 2 mid-dose patients here. And they plan on doing up to 9 in this study, so it could be good. One thing, they said that plasma IDUA activity was not significantly changed from pre-treatment values. So, again, we're kind of left wanting with this data. As nice as it is to see it in cells that this goes up, it's anybody's guess whether or not this is an artifact due to the ERT treatment, because these patients are getting ERT, and there could just be something going on where the time points that they measure happen to coincide with increases in the leukocyte activity. And, we can see that here, even if you look at subject 2, before treatment, there's a range of between 5 and 10, and then it went, down to 3 before treatment, and then spiked back up. So, I don't know if this is clinically relevant or meaningful. And I think for the company guys to be super excited about this and hang their hat on this as being, a reason why we should think that this worked, I think is ambitious. And, it shows up in the GAG levels. So, this is just very variable data. And it's cute, the way that their scale is here. They kept the scale the same for all the subjects, but if we increase that scale, the amount of movement in the GAGs, this could just be normal GAG fluctuations due to ERT treatment that occurs. And I don't know, I'm just super skeptical now, given what we've seen and given what I think they could produce to settle everybody's concerns about the technology. And because they're continually holding back on that, I'm just less inclined to give them the benefit of the doubt, which I did before. And, my 15 shares suffered for it. So the things to look out for the rest of the year, basically, is they're going to present ERT withdrawal data from these patients. They're going to give updates on their hemophilia programs, and as well as some beta thalassemia updates. So there's definitely going to be a big readout throughout the rest of the year, and it's really going to dictate the future of the company, in my opinion. So overall, here's what I got. I don't think the ERT is going to work. If we look here, there's barely any increases in IDS levels, and I don't think it's going to be enough to bring the GAGs down that's going to lead to any clinically meaningful result. So they've already had one patient have to go back on ERT, and I think the rest of them will follow shortly after. And, these are just my opinions. Take him or leave him. Leave me a comment or something, but none of this is financial advice, and I don't expect anybody to invest based on this. But, so I don't think that the zinc finger 2.0 tech is going to fix the issue. The zinc fingers might work fine. It could just be the virus. And if it is the virus, we need to be concerned about the hemophilia B program, because it's the exact same setup. Same zinc fingers and the same insertion into the albumin gene. And if that's the case, it could be a similar story. Now, the SB525 program is only one vector, so they just put the cDNA in the cell, and the cell seemingly can just produce that protein, and it should be no problem. But the hemophilia B program might be in jeopardy if you think, like I do, that there might be a problem with the virus. The other hemophilia programs I have, beta thalassemia and sickle cell disease, it's ex vivo gene editing, so it's a lot easier to get a gene into an ex vivo cell, and that's just a cell that's taken from the body, than it is to actually infect cells that are in the body. So I think there's a much higher chance that these programs will have success. So I'm mostly worried about the hemophilia B program, but I don't know. This could all change if we show good data at the end of the year. So, it's just, there's a lot of risk associated with this company right now. So, their market cap after the drop is $800 million. Their net cash about $350 million. at the end of the year, and they lose about 15 per quarter, so they're decently funded to continue these programs. It's just how long are you willing to wait before they strike gold? And they're already behind compared to a lot of the competitors regarding the hemophilia programs. So, I'm not sure. But I think they're fairly valued here for the delays in these MPS programs. But I think if the withdrawal fails, the ERT withdrawal fails or the hemophilia programs fail, there's probably more downside to come. So I'm waiting for some sort of bounce just for luck, and I'm going to sell my 15 shares. I just, it's a little too risky for me at this moment. So this is what happened. We're at 772 right now, and we'll see. But that's pretty much it. I think I covered everything I wanted to for the program, for the Sangamo. But my goals for this week are to fix my laptop. I think the water damage is going to need me to replace the motherboard, which sucks, but it's a hard-fought lesson. On the macro scale, I think the entire market is waiting for these things. So U.S.-China deal that could occur, the tariffs, the U.S. imposed tariffs on China should go into effect March 1st if there's no deal. So, get ready for Trump to tweet a whole bunch, and that could really change the trajectory of the market. There's also another government shutdown looming, which, it seems like the market doesn't care too much about government shutdowns, but it's still, newsworthy and still could affect things. In the biotech world, I'm still waiting for the NASH data, which I'm excited about. And Catalyst Biosciences actually released some updates on their data, which I found kind of interesting. So I think this week I'm going to do a deeper dive on them, because I think their market cap's only 100 million, and they have some hemophilia products that would probably be well received by the market, I think. So I'm going to do a deeper dive on them and probably present that next week. But that's all I got for you guys this week, and thank you all for watching and through my technical issues that I had. But with that, we'll see you next week. Have a good one.